Often in statics and in your future classes, you will end up with several equations and you will need to find the unknown variables. Some of these equations can have only one variable, while others can have multiple variables. It is always beneficial to know how to solve for the unknowns in these equations. Often, multiple equations that are used to find the unknowns can be thought of as intersections of all the equations, or that they satisfy all the conditions given, such as maximum forces. In order to solve for the unknown variables, you will need as many equations that express them. There are several ways that multiple equations can be solved, and it will be up to you to decide what is the best way to solve them. The three that I will cover are substitution method, matrix method, and the electronic solver method. You can always row reduce, plot them, or anything else that works for you. One of the easiest ways to think of solving multiple equations is finding the intersection. Here we have three planes that intersect at one point. That means that in all of space there exists one point that will satisfy all of the equations for these planes. If you were in a situation where you didn't have as many equations as you did unknowns, you would have more than one possible answer. If, for example, we took away one of the planes in this picture, we would have a line that describes all of the solutions, which would be infinite. So in other words, you will need as many equations as there are unknowns in order to get exact answers. Here is the example problem that we will be solving three different ways. Here are the three independent equations that have a solution, which means there is one x1, one x2, and one x3 value that will satisfy all three of these equations at the same time. It doesn't matter too much what these equations represent for now, but you can make your own equations with your own problems in the future. Hopefully you can pay attention to some of the methods that I use and can implement them into your own problem-solving skills. The substitution method is the most reliant method to get answers. Sometimes it is difficult to accomplish, but it will always give you an answer. Usually people avoid this method because there are several steps, and if you make a small mistake, it has dire consequences. If you always check your work, you should always get an answer, however. Sometimes electronic solvers and matrices won't be usable to find solutions to equations that contain more complicated functions, such as logarithms. I find myself going back to substitution quite often in order to solve some of my more complicated questions. When working with substitution method, I always start with one equation. I usually try to find the simplest or easy equation with the least amount of unknowns. In this case, there are the same number of unknowns in each equation, so there is not an easy way around it. I'm going to start with the first equation and solve for x1. To solve for it is pretty simple. I usually just move all the other variables and constants to the other side of the equal sign. Then I divide or do whatever operation is easiest to find the variable. I will be able to find x1 in terms of x2 and x3. Now that I have found x1, I need to substitute it into the other equations. That is why this is called substitution. Now if I substitute it into the second equation where x1 should be, I get this equation right here, which looks quite confusing. So what I'll do is simplify it through distribution and simple math. Now I'll be able to solve for x2 the same way I solved for x1. Now I have x1 in terms of x3. Now that I have x1 in terms of x2 and x3, I should be able to substitute x2 into it and find x1 only in terms of x3. So now I'll take the little equation that I derived for x1, and I'll go ahead and substitute the values for x2. And then I just do the same process where I simplify it, and I will get x1 only in terms of x3. Now I have x1 and x2 in terms of x3. I can use both of those now and substitute them into the final equation to find my x3 number value. All I have to do is, of course, is the simple math that we've been doing up till now. I'll distribute the 25 and the 37 in this case. And I'll have this big, huge, long equation. And then all I have to do to simplify it further is do some simple addition and subtraction. And then I have to finally do some division, and I get the answer for x3 to be 4.713. Now I have an exact number for x3 that satisfies all three of those equations. Now, all I have to do to find x1 and x2 is substitute that value that I got for x3 into their respective equations. And now I get the values for x1 and x2 to be 5.791 for x1 and 3.411 for x2. Now that wasn't that hard. It's just a very long process and it's easy to make a small mistake. So here are our final answers. The matrix method is a popular method because most calculators use this method to run their solvers. If you use a calculator to do this, chances are they will be quite simple. This can also be done in Excel quickly. I'll show you how to do this problem in Excel, but I'll explain how you can do it in a calculator as well. There is one requirement for the matrix method. The equations must be linear. You can't use this method if you have more complicated equations for your unknowns. To explain how the matrix method works, we are going to use the equation of matrix A times matrix X will equal matrix B. Matrix A is made up of all the coefficients of your unknowns in the equations. Sometimes they will be 0 or represented with trigonometric identities such as sine of theta. And sometimes they will be simple constant numbers. The rows will be made up of your equations in this case. So the row with AB is one equation, and the row with CD is another equation. Make sure that the columns are the coefficients to the same variable. So my column AC is going to be related to my x1 variable. My column BD is going to be related to my x2 variable. Your matrix X is a matrix made up of your unknowns. Here you will simply list your unknowns in rows in the same order as the columns that you ordered in your A matrix. Your B matrix are the answers to the equations. This will be a number without any variable attached. If you have an equation with any constant values on the same side, you should move them over to the constant side of the equation. That might mean you have to add or subtract them. That way, on one side of the equation, you will have unknowns with coefficients, and on the other side, you will only have known values. Each row will correspond to the same equation described in matrix A. So that means that the equation with coefficients A, B will have the answer E. Now that we understand our matrices, the proof that goes into how the matrix method works is when we take the inverse of our A matrix and multiply it to both sides of our equation, and we get that X is equal to A inverse times B. Now, I wouldn't suggest doing this by hand, but you can. I'm not going to teach you how to take the inverse of a matrix. That will be covered in some of your future math classes. But I'll do it in Excel and show you how to make this really easy. Now we're going to find the solutions to these three equations using the matrix method. How I usually do the matrix method in Excel is I write down the equations that I need to solve for, and then I make a small table. First, I'll make a column for my equations. Then I'll make one for each respective variable. In this case, it will be x1, x2, and x3. And then I'll make a column for my answers, which are just going to be all the constants. Now that I have the labels for each of my columns, I'll go ahead and start putting stuff here. So for the first equation, I gotta go take what's the coefficient to x1, which in this case would be 3. And then for the second coefficient will be 5. And the third coefficient will be -2. And then the answer should be equal to 25. Now one thing with the answers is if for some reason you have some constant value on the other side of the equal sign, all you need to do is move it over. So if you have 3x1, 5x2, -2x3, minus 25, you'd have to move the minus 25 over to the other side of the equal sign, and you'd get positive 25. Now I'll go ahead and write equation 2. We have 33, -25, -32, and it's equal to -45. And then equation 3 is -25, 37, and 5, and it's all equal to 5. Now if you remember, now we need to basically get the inverse of this. So I'll make a small section here and make it the inverse. We can use in Excel and create matrices by selecting a region that we want the matrix to be in. And all we need to do for the inverse is go equals to M inverse. Now we select the matrix that we want to invert, which if you remember is this section right here. It's all the coefficients to our matrix. We close it off, and then we have to hold Control, Shift, Enter. And when you do Control-Shift-Enter, it will populate the cells. If you don't do it like that, you won't get all these values. Now that we have our inverse matrix and our original matrix, all we need to do to find the final answers for our x1, x2, and x3 values. First, we have to select the range where we want our answers to be. Then we want to do an M-mult, which stands for matrix multiplication. And we'll select first our inverted matrix, and then second our answers matrix. And when we take those two and do Control-Shift-Enter again, we'll get our answers. 5.7, 3.41, and 4.713. The electronic solver method is by far the easiest way to solve multiple equations. I will be showing you how to do it in Mathematica, a program provided to all students of BYU-Idaho. You can search on the BYU-I website with instructions on how to download and install it. There are other electronic solvers like apps that can be downloaded to calculators and MATLAB. Some things to keep in mind about electronic solvers are they are usually the easiest method to find your answers. Often they can be set up differently based on the program, and each program has their own specific limits. Usually also it's a good idea to note that they cannot be used on tests. Now I'll go ahead and show you how to do the same example problem in Mathematica. So now for an electronic solver, I'm going to show you how to use Mathematica. Mathematica is a very powerful tool and is very useful for solving simultaneous equations. When we want to solve a simultaneous equation, we can usually use the solve command. When you use a command in Mathematica, you start, after you've typed out your command, you need to write a square bracket. It should be on your keyboard. Another thing about any function in Mathematica is you need to make sure that every word is capitalized. And then we need to make a list of all the equations we want solved. So we'll put a curly bracket. A curly bracket just means list. Now we can go ahead and type out our equations. You can push enter and you'll start a new line. It'll be within the same code. As you notice, the solve command is highlighted. And you can start writing your equations. So our equations are 3 times x1 plus 5 times x2 minus 2 times x3. And that should all equal 25. In Mathematica, when you're using the solve function, you have to push 2 equal signs. Else it'll try to define that equation as equal to 25. Now to get our next equation, we just will separate it with a comma, and we can push enter again. And we can start writing the next equations. So 3 times x1 minus 25 times x2 minus 32 times x3, and that's all equal to negative 45. Then we'll do another comma. We'll have negative 25 times x1 plus 37 times x2 plus 5 times x3. That should all equal 5. And now that we're done with all our equations, we can close it with our list with a curly bracket. Now that we finish our equation, we put comma, and then we need to put the next part of the solve function, which will require us to make a list of all the variables that we want, which we want x1, x2, and x3. And then we'll close that list, and we'll close the function. If you notice, everything looks nice and neat, closed off. All those variables have now been highlighted green. To get our final answer, all we need to do is push Shift-Enter. And then you might go and notice, hey, there's a lot of fractions, and that's not very helpful. So if you wanted to get in actual numbers, you can type 2 forward slashes and a capital letter N, and that will give you a numeric approximation instead of fractions. And these are our answers for x1, x2, and x3.